the adrenal glands themselves don't just give up. Oh, I can't take it, I'm out of here. They don't do that. It doesn't happen. It's a made up term to sell products and sell courses and to sell supplements and sell food. It's bull. It's nonsense. It doesn't happen. So, and high intensity training cannot cause adrenal fatigue because adrenal fatigue doesn't exist. That's like saying
this is a huge thing that you, Doug, Mike, a lot of people speak on, but most of this is marketing bullshit, number one.
Right.
And number two, if all humans were different the way that people said we were all different, doctors wouldn't have a job, nurses wouldn't have a job, okay? Like physics applies to you, chemistry applies to you, the same as everyone else.
Right.
Hello and welcome. I am Coach Castle, a certified biomechanics expert, nutritionalist, and efficiency coach. Subscribe to this channel to learn the most efficient ways to maximize your muscle growth and recovery, enhance your body, and advance your mind, all using the latest science. Welcome to Castle's Corner.
Now, there's a couple of critiques. I don't know if you were going to talk about this, but there have been some critiques against high-intensity training. I'm sure you're familiar with some of them. Some of them use, and Mike used to talk about this too. They say that training to failure all the time causes a type of stress syndrome that leads to something called adrenal fatigue, where you're basically adrenal glands break down. Well, I looked into that, and I looked into the science behind that, and I actually wrote an article in my Applied Metabolics newsletter about adrenal fatigue because it's a popular term. They sell books, they sell supplements, all to treat this so-called adrenal fatigue
thing. Yeah.
Well, the truth is, in medicine, any doctor who knows his physiology will tell you there is no such animal. Your adrenal glands don't just give up like that. What happens is there's certain diseases where there's problems with the adrenal glands. Two, for example, one of them is called Addison's disease. President John F. Kennedy suffered from that. Basically, what happens is you do have an adrenal failure where your body is not making hormones like cortisol, so you have to be supplemented with that. And there's another type of thing called Cushing's disease, which is the opposite. This involves excessive production of cortisol. Cushing's disease usually involves a tumor. They have different kinds. There's one called pheochromocytoma that are involved in the adrenal glands. But my point being, the adrenal glands themselves don't just give up. Oh, I can't take it, I'm out of here. They don't do that. It doesn't happen. It's a made-up term to sell products and sell courses and to sell supplements and sell food. It's bull. It's nonsense. It doesn't happen. So, and high-intensity training cannot cause adrenal fatigue because adrenal fatigue doesn't exist. That's like saying
this is a huge thing that you, Doug, Mike, a lot of people speak on, but most of this is marketing bullshit, number one.
Right.
And number two, if all humans were different the way that people said we were all different, doctors wouldn't have a job, nurses wouldn't have a job, okay? Like physics applies to you, chemistry applies to you, the same as everyone else.
Right. Well, yeah. And another I've seen this in a couple of articles. Another critique of high intensity training to failure is a couple of studies have found that when you train that way, for some reason, you blunt the release of insulin-like growth factor 1. I don't know if you've heard that one. Now, we need a brief explanation of why that's important. Insulin-like growth factor 1 is produced basically in two parts, well, two areas of the body, let's say. The first one is we call systemic insulin-like, let's call it IGF-1. Systemic IGF-1 is produced in the liver under the aegis of growth hormone. When growth hormone is secreted, it goes to the liver, and immediately the liver starts to produce insulin-like growth factor 1. That's a systemic hormone, very important for health. It maintains your neurons in your brain, it maintains your heart muscle cells, and maintains your connective tissue. Without insulin growth factor 1, to put it simply, you would fall apart. It'd be like one of those houses you ever see where they just fall apart. That would be happening. And there's an interesting correlate to that I'll mention in a second, but the second area where insulin-like, and this is more pertinent to working out, is you have a kind of, I think they call it autocrine, insulin-like IGF-1 produced in the muscle. When you work out, you of course, the old idea that you damage muscles and then your body rebuilds the muscles, and that's how the muscles grow. There's a certain amount of truth to that. But what happens is when you work out hard, you stimulate the release of localized IGF-1 in the muscle. What does it do? IGF-1 stimulates, it turns on those, remember I talked about those satellite cells, those stem cells? It not only turns it on, but it promotes differentiation, which is very important for muscle growth, because when the muscle stem cells basically kind of, I'm simplifying this, it's a lot more complicated, but when they lock on to the damaged muscle fiber, not only do they repair the muscle fiber, but they contribute what they call myonuclei. A muscle cell is unique because unlike other cells, it has many nuclei, and they call it myonuclei. And the myonuclei those are the areas of muscle protein synthesis that basically produce the protein that increases muscle mass. So IGF-1 is very important for muscle growth. Now, before I explain about the connection between high intensity training and IGF-1, I should mention that there's a big controversy in medicine. The animals that have a resistance to IGF-1, meaning the bodies might produce it, but at the level of the IGF-1 receptor, the IGF-1 is less active. They live up to 30 to 40% longer. And they found that old people that live to over 100 also have that same mutation. And they think that having that type of, let's say, resistance to IGF-1, somehow extends life. The theory of why it does that is because tumors, IGF-1 unfortunately stimulates mitosis, which is cell division. What is cancer? Cancer is uncontrolled cell division. The idea is that IGF-1 will cause a tumor to actually more rapidly divide. Therefore, it increases the possibility of cancer metastasis or possibly killing you. Now, here's the big debate in medicine. Nobody really knows whether the systemic IGF-1 stimulates tumors or whether it's the tumors themselves, because tumors themselves produce IGF-1. Why? Because IGF-1 does something else. It prevents cellular apoptosis. What is apoptosis? Self-destruction. Cells, the body's marvelous. The cells can tell when there's something wrong. The cell can detect when there's a mutation coming on. And what it does is it kills itself, literally blows up. It's like, they call that apoptosis. Unfortunately, IGF-1 prevents that. So you can see tumor cells will actually produce IGF-1 to prevent the self-destruction of the tumor, apoptosis. So again, the big debate in medicine, we don't know whether it's the systemic IGF-1 that's doing that or the IGF-1 from the tumors. Personally, I think it's the IGF-1 from the tumors, because if it was IGF systemica, that means everybody would be getting cancer. And who has the highest levels of IGF-1? Teenagers. Teenagers secrete the most growth hormone in IGF-1. If IGF-1 truly caused cancer, like some people like to say, then all these teenagers nobody would ever survive. We'd all die of cancer in our teenage years. See?
I mean, basically, yeah. I mean, that makes logical sense to me.
Yeah. So you see, it's a kind of a conundrum. You know what I mean? But they do know that IGF-1 has a relationship to longevity. But how it does it, the cancer thing is kind of up in the air. Nobody really knows, but in animals and humans, there seems to be some sort of relationship. But you have to look at it from the flip side. If, let's say, somebody might say, well, Jerry, what if I just cut off IGF-1 somehow and make it where you don't produce any at all? Well, that's very bad because, as I said earlier, IGF-1 maintains brain cells, heart cells, connective tissue. If you cut off your IGF-1, you literally fall apart. In fact, they have an expression in biology called antagonistic pleiotropy. What it means is what's good when you're young actually can hurt you when you get older. In other words, IGF-1 and growth hormone are very good when you're young because they help you grow. You know what I mean? They, this and that. Unfortunately, when you get older, having excess of either one, growth hormone or IGF-1, is related to the increased possibility of cancer. There's another one called P53. P53, when you're younger, as an anti-tumor gene, it helps to prevent cancer. Unfortunately, as you get older, it stimulates the aging of cells. So as you get older, it still prevents cancer, but it also kills you at the same time. Unfortunately, that's Mother Nature's trick on all of us, But getting back to the high intensity training, The idea is that somehow going to failure or using extreme high intensity causes changes in the muscle where the muscle will not release enough IGF-1. It'll blunt the release of localized IGF-1 in the muscle. Here's my problem with that. If that was true, then anyone who uses high intensity training to failure should, I'm not talking about the guys on steroids or taking exogenous growth hormone. I'm talking about naturals. If that were true, any guy or man or woman using high intensity training should show no muscle gains at all.
It'll be
Nothing.
going backwards, yeah.
It'd be going backwards.
Yeah.
It's as Arthur Jones say, it was expression he used, kind of something related to common sense logic. In other words, it's obvious that it can't be true, because if it was, again, none of these people would making not one iota of gains. They would have no muscle. Guys like Mike, even with the steroids.
I mean, outcomes razor, whatever the simplest solution. It makes the most sense,
exactly.
obviously.
Right. So let me put it this way. If high intensity going to failure training does blunt IGF-1, it probably only partially blunts it, not to the extent where it'll prevent muscle growth. That's my hypothesis. I don't have any proof, for that speculation, but it's just obvious,
Is there any way possible it actually stimulates it, so it produces more of it?
That's another thing. It should, because
I would think it would.
Think about it. When is IGF-1 in the muscle, autocrine IGF-1, when is it produced? It's produced when the muscle's damaged.
Yeah, it has to be.
It's a repair mechanism. What do you do when you do high intensity? You damage the muscle.
Yeah, again, I would think it would produce more of it, not less of it.
I would too.
I don't know. I haven't done a biopsy. I don't know. You'd have to do a biopsy like immediately after the workout, I guess, right?
Yeah.
Or during and after.
Yeah.